Hi, you're watching Saturday in the Woodworking Shop with Andrew Pitts, where we talk things woodworking. How do you measure the dryness of wood? Well, in my shop there's pretty much four ways. The first way is you bring the wood in and you just let it sit for a few years, and eventually it'll get to the same moisture content that's equivalent to the humidity in the space, and it's dry. But that takes a long time. The second way is the oven dry method of testing, and it's very accurate. What you do is you take a sample of the wood, usually a small piece, and you weigh it very accurately, and then you put it in an oven set to about 217 degrees and leave it in there for about 24 hours. Weigh that again. Put it back in the oven for a few hours, weigh it again until the weight stops changing. At that point, you know that your sample is dry, completely dry. Okay, the moisture content is the weight of the water that was in the wood divided by the weight of the oven dry sample. So take that initial measurement you made of weight of the wet piece of wood, subtract from it the weight of the dry piece, gives you a number. Divide that number by the weight of the dry piece, and that gives you your moisture content. And that's really accurate, but it only measures a little sample, and it kind of takes a long time to do. So a more practical way of measuring your moisture, for everyday use would be an electrical moisture meter. And I've got two types. They're both described in a publication from the Forest Products Laboratory. This is publication FPL-GTR6. It's called Electric Moisture Meters for Wood. So if you go to the Forest Products Laboratory website, you can download this on a PDF for free. It gives a lot of theory about the different types of moisture meters, so if you're in the market for one, it's a useful read to kind of get a feel for how these things work. The first type I have is called a pin type moisture meter. It actually measures the electrical conductivity of the wood using two steel pins that drive into the wood. Now this type of meter is accurate below the fiber saturation point. That is where there's no more free water in the cells and all you have are the cell walls saturated. From that point, which is about 30% moisture content on down to zero, the meter's fairly accurate. As a matter of fact, my meter pegs out at 30% moisture content, so it doesn't even show anything above that. If you drive the pins into the wood about a quarter to roughly a quarter of the thickness of the wood, you'll get the average moisture content for the entire piece of wood. Maybe a little more moisture in the center, a little less on the edges, but if you go down about a quarter of the thickness, you'll get a good reading. Now, this measures, like I say, the electrical resistance between the pins, and my manual says to keep the pins perpendicular to the grain. So the grain's running front and back, the alignment of the pin axis is perpendicular. And I'll use this hammer type of a handle here to drive my pins in. There's a little meter on the top here that shows you how far in you've gone. So there I am, about a quarter of the way. And then I make sure I got my group species setting correct. They give you a little card with my meter, and it says that walnut is in group 3. So I set this to group 3. Press my button, and I'm getting about 8%, maybe 7.5 to 8% moisture content at this particular place. Okay, there's a couple of different pins that you can get with this as well. The ones that are in here right now are 1-inch long steel pins, but if you have a little surface moisture on your wood, maybe there's some dew in the morning, and you don't want that to affect your reading because this is going to read the wettest part of the wood, then they make insulated pins. There's insulation on this. These are 2-inch pins. Goes from just below the tip down to the base. The tips are uninsulated, so when you drive that in, your only reading is going to be at the very, very tips. Also, with this particular meter, the conductivity is directly proportional to the temperature of the wood. It's calibrated for 20 degrees centigrade, which is about 68 degrees Fahrenheit. That's what we have in this room right now. So I know that this board right in here where I measured is probably about 8% moisture content. But if it's warmer, say in the kiln, I know that the conductivity of the wood goes up as the temperature goes up. So if I was measuring 8% moisture content, I probably have drier wood than that because it's really conductive and it's kind of fooling the meter. So I go to my card here and I'd say, okay, let's see, 8% moisture content at say 104 degrees. Maybe that's how hot it is in the kiln when I'm measuring it. That means I really have 6.5% moisture content. On a colder day, say it's 41 degrees outside and I'm measuring 8%, go to my little card here, I really have 10.5% moisture content. So that's important consideration. I use this meter a lot because I can get into the edge of a board when it's in the kiln, and it makes it very convenient for me to take some readings. The downside of this meter, of course, is that it leaves some pinholes. So I've got a different kind of meter that I use in that case. Now, the other type of meter I have that does not leave pinholes is a pinless moisture meter. This is a Wagner MMC 210, and the way it operates, it creates an electromagnetic field around this sensor portion so that when you set it onto the wood, the moisture in the wood will cause some distortion of that field, which is measured by the device, and it can tell you the moisture content. The nice thing about this is you can move it all around the surface. It doesn't leave any marks, so you can figure out how much the moisture content varies in the piece. Now, with this meter, you have to set the specific gravity of the wood, and that specific gravity, that is the ratio of the density of the wood to the density of water. They give you a little species chart, and for walnut it says to set the species at 0.55 specific gravity. So you push the species button, and I've already got it set to 0.55 specific gravity. So you push down on the meter with about 3 pounds of force, and you move it around, and I'm looking at that place where I did the pin type calculation there, and I'm showing 9.3, 9.4, but you notice that that reading was a little higher than what I got with the pin type meter. And there's a lot of things that can affect that. You know, the pin type meter just being in one very specific little place. But if you ever do have doubt that the reading is not proper, what you can do is you can measure the actual specific gravity of your real piece of wood. So what you do is you measure the volume very carefully of your sample, and you calculate the cubic feet of that volume. You take that and then you weigh the wood and divide the volume into the weight, and that gives you the density of the wood, pounds per cubic feet. Compare that to the density of water by dividing that 62.34 pounds per cubic foot of water density. So you got the wood density divided by the water density, and that's going to give you a fraction. And in the case of walnut, it's supposed to be 0.55. If you find that that number is different, maybe it's 0.6 for your actual sample, go ahead and set that into the meter and you'll get an accurate reading. Now, the one drawback to this meter for my particular use in the kiln is that it's wider than my stickers, so I can't really get it in between the the layers to really get a good reading on that. Another thing that this is designed for wood that's at least 3/4 of an inch thick up to about 1.5 inches thick for this particular meter.